Section 5.5, example 2, using the factor theorem to find the zeros of a polynomial expression. Show that x minus 2 or x plus 2 is a factor of x cubed minus 6x squared minus x plus 3. Find the remaining factors. Use the factors to determine the zeros of the polynomial. All right, let's give it a try. So let's start with our actual function here, or our expression. It's not a function because it doesn't even have equal to sign. So let's look at the function here. Make sure that there's a representative for each of the terms. I see that it's already in decreasing degrees. So x cubed squared to the power 1 and x to the power 0. So we have a representative for each of those. So we could start putting it in our synthetic division part here. The coefficient 1, coefficient -6, -1, and 30. And now they're telling us that this is one of the zeros. So we have x plus 2 equals 0. So what we're going to do is x equals -2. This is what we're going to use here, -2. And start doing our synthetic division. So we have 1, -2 times 1 is -2. -6 is going to be -8. -8 times -2 is going to be +16. 16 minus 1 is going to be +15. 2 times -2 times 15 is going to be a -30. And then 30 minus 30 is going to be 0. So now we originally had x cubed minus 6x squared minus x plus 30. Now we just learned that x plus 2 is one of the factors. So x plus 2 is one of the factors, and we're going down in degree. So this here was originally x cubed. So down here, this is going to be 1 degree less. So instead of x cubed, it's going to be x squared. So x squared, then minus 8x, and plus 15. And we have that. And now we actually have plenty of tools to help us factor this part. We could factor just normally. I'm going to say just using our x method. So finding two numbers that multiply to 15 that add to a -8. It looks like it's going to be -3 and -5. -3 times -5 gives us our +15. -3 minus -5 is going to be a -8. So we have x plus 2. We also have x minus 3 and x minus 5. So this is our expression completely factored. So find the remaining factors. We found that. Use the factors to determine the zeros of the polynomials. So now we're just going to set each of those equal to 0. X plus 2 equals 0, x minus 3 equals 0, and also x minus 5 equals 0. So we have x equals -2 here, x equals 3 here, and x equals 5 here. So our zeros is when x is -2, our output ends up being 0. When x is +3, our output ends up being 0. And also when x is +5, our output ends up being 0. And there we go. If you have any questions, please feel free to ask. Otherwise, bye.